Hi, and welcome to the Introduction to Modern OpenGL tutorial series. I'm Steve Jones, and I'm with the Game Institute. In this series, I'm going to teach you the fundamentals of the OpenGL graphics library. OpenGL is used to draw hardware-accelerated graphics because it talks directly to your video card, takes advantage of the GPU, or graphics processing unit. This series of video lectures is a tutorial in modern OpenGL for 2D and 3D graphics programming. We're going to learn the modern way of OpenGL. The web is full of tutorials and other resources on OpenGL, but most of these are focused on the old way, or immediate mode way, or fixed function pipeline. I'm going to talk about that a little bit later. This series is meant to show you step-by-step instructions on how to use OpenGL along with easy-to-follow code examples. So what will you be learning in this course? Well, you're going to learn the fundamentals of modern OpenGL. You're going to learn the newest API and how it works, and you're also going to get a little history of OpenGL in this video, but I'm not going to go into extreme detail. You can always go on the internet and find out more about the history. You're going to learn the graphics, the hardware graphics pipeline in this series. It's going to show you how OpenGL transforms data into pixels that show up on your screen. You're going to be able to create and initialize a window to draw in. OpenGL is a cross-platform library, and it does not include any windowing or input functionality. It's strictly for rendering graphics. So we're going to be using a third-party library to create a window for us, and we're going to get into that a little bit later. You'll be able to draw in that window using OpenGL and its newest techniques. You're going to learn in this series how to program the graphics card with little mini programs called shaders. Okay, so what should you know before you continue on in this course? What are the prerequisites? Well, you should know C++ programming. I'm not going to teach you programming in this course, so if you need to, the Game Institute has some great courses on C++ programming. I would recommend that you jump on over there before continuing on in this series and learn programming. You don't need to be an expert, though. You should have some basic high school math knowledge, like trigonometry, like sine, cosine, and tangent functions, 3D math involving 3D vectors, matrix math, dot product, cross product, those kinds of things. We're going to be using those in this course. I'm not going to be teaching them per se. So again, 3D math is foreign to you. I would encourage you to go to the Game Institute. There's a great course on math that goes into great detail on it. Plus, or you can also go on the web and find resources there. But we'll be using math. We're not going to be teaching it per se in this course. Hardware. You should have a computer that has a graphics card that supports at least version 3.2 and higher. Now, if you have a computer that is 10 years old or earlier, then you'd be fine. Now I'm going to be doing all the code in Windows, but since OpenGL is a cross-platform library, you could use Linux or Mac, but I'm not going to be jumping over there to those other operating systems. We're going to stick to Windows. So before tackling hard things, it's always a good idea to try to understand them on paper first before jumping right to code. And from time to time on various topics, we're going to be doing that. Although we won't have paper, we'll be doing it on the screen, but it's a good idea to do that before going straight to code. So what is OpenGL? OpenGL, or Open Graphics Library, is really a high-level interface to the graphics hardware. And very specifically, OpenGL really just defines an interface or set of requirements for 2D and 3D graphics rendering. The actual API, the requirements, how is really implemented by the manufacturers of the hardware, the video card hardware. So the quote there from the OpenGL 3.3 specification says OpenGL basically is a bunch of functions and things like that that allow the programmer to render graphics and take advantage of hardware accelerated graphics or your video card. So being just a specification, it's really up to the graphics card manufacturers like NVIDIA, AMD, and Intel to implement the interface. OpenGL doesn't dictate how to implement the API. It's up to each graphics card developer to do it, but they must comply with the API requirements. So this table is showing you a bit of the history, the versions, and when they were released in OpenGL. I wanted to highlight that in this course, when I talk about modern OpenGL, well, here it is. It's version 3.2 basically and higher. So OpenGL really has come a long way. I'm showing some different screenshots from id Software games and recently Bethesda. It really has come a long ways since the early 90s. So you might be wondering, well, does my computer support the version of OpenGL that's required for this course? And that is by using a handy little utility you can download for free from the web called the OpenGL Extension Viewer. So when you run it, you can tell what version you have. So in this case, I have a Quadro 5000 video card, and the current version of OpenGL is 4.2. That's a great little utility to tell you what version you have, plus a whole lot more. It tells you all the extensions that are supported by the driver of the video card that you have in your system. So I mentioned earlier about old versus new, and in this course we're sticking to the new. Well, what does that really mean? Well, the old way, called immediate mode, uses a fixed function pipeline. It's easier to program and easier to use, but much of the functionality, it was hidden from the programmer. So you didn't have a lot of control over how the rendering was done. It was fixed. So developers lack the freedom and control to do their rendering, plus the fixed function pipeline is inefficient. So in 2008, the ARB decided to fork the specification into two profiles, core and compatibility. The core profile is what we're going to be focusing on completely in this course. The compatibility profile really only exists for developers to maintain their legacy applications. They don't have to, if they want to use the newer API, it doesn't break their apps. They can select the compatibility mode when they first initialize OpenGL, and it won't break their apps. But on the flip side, it will allow their apps to run much faster. But for new graphics applications, the ARB strongly encourages you to use the core profile or the new way. So that's what we're going to be learning in this course. The core profile forces developers to use modern functionality. And when you try to use one of the depreciated functions, which is what is found in the compatibility profile, OpenGL raises errors and stops drawing. The modern approach requires you to really understand what's going on. And that's what we're going to try to accomplish in these videos. These tutorials will be using the core profile OpenGL version 3.3. So if you remember the version table in a previous slide, you might be asking yourself, why aren't we going to use the very latest version? And as of this recording, the latest version is 4.5. Well, there's a couple reasons. One, versions after 3.3 don't really change the basic fundamental core mechanics of how to draw things. Features have been added since 3.3, but generally how you draw things is done the same way, fundamentally. So that's one reason why we're gonna stick to 3.3. The other reason is if you do happen to have an older computer that doesn't support the newer versions of OpenGL, it's going to be hard for you to follow along. So that's why we're going to use 3.3. So there you go, a brief history of OpenGL, but enough talk. We need to get programming. So let's go ahead and get started.